Hi, and welcome to Recording 1A in our series on trigonometric ratios of any angle for Unit 2, Chapter 2, Trigonometry, Mathematics 2200. In this recording, we focus on trigonometric ratios given a point on the terminal arm, and we'll be expressing them in exact form. Quick recall. If you have an angle, we'll call it theta in a right triangle. The sine of that angle is equal to the opposite leg divided by the hypotenuse. Cosine theta is equal to the adjacent leg divided by the hypotenuse, and tan theta equals opposite over adjacent. One point of note for a right triangle is that other than the right angle, the other two angles are always acute. The problem with angles of rotation that we've been talking about in our previous recordings is that they're not necessarily acute angles. Let's see how we deal with those. Suppose you're given a point on the terminal arm of an angle. Here's our angle in standard position, and we take a look at where the terminal arm lies and think about its reference angle. We make a right triangle from the point on the terminal arm to the closest part of the x-axis. So we just draw that perpendicular line right there. Then, to determine what's opposite, adjacent, and hypotenuse, we'll use the reference angle. So for the sine of the angle, the opposite is y, the hypotenuse is r. So in other words, the sine of the angle will be the y value divided by r. We call that side, this side here, r, by the way, because it is really the radius of a circle that we just haven't drawn right here. Cosine of theta is adjacent, which is the x. That's the adjacent for the reference angle, and the hypotenuse is r. And the tan of the angle is the opposite, which is the y value divided by the adjacent, which is the x value. So now we've got a way of determining the sine, the cosine, and the tangent of any angle from standard position. So even though we use the reference angle to determine what's opposite, adjacent, and hypotenuse, those values, y over r for the sine, x over r for the cosine, and y over x for the tan value, they're considered to be the values or the trig ratios for theta, not for theta sub r. Let's have a look at how this works in practice. Find the exact values of the primary trigonometric ratios for theta in this diagram. We begin by dropping a perpendicular line from our point on the terminal arm, and I make that a right angle there. So that makes this side, it's -3 units. Going up, it's 4 units. Now we need to figure out what our r value. So the first thing we need to do is use our Pythagorean theorem. -3 squared. Be careful to put brackets around that -3. If you put a -3 squared on your calculator, like this, you will get -9. We don't want that. We want -3 all squared to get +9. And then we have +4 squared equals r squared. So we have 9 plus 16 equals r squared, and therefore 25 equals r squared. Therefore, our r value is the square root of 25, which is 5 in this case. Now, we're asked to find the exact values of the primary trigonometric ratios, so that means we want sine theta. That's your y value over your r value, your opposite over your adjacent, from the reference angle. Here's your reference right here. So the opposite is 4, and the hypotenuse is, now we know to be 5. So it's 4/5. Cosine theta, x value over r value, -3 over 5, and tan theta equals y over x. Didn't even need the Pythagorean theorem for that one. It becomes 4 over -3, but we like to move the negative sign to the top of the fraction. On to the next example. Find the exact values of the primary trig ratios for theta again. So we drop our perpendicular line to our terminal arm here. Just drawing things freehand. So this side here is 4 for the triangle, -5 for this one. We're looking for r. Pythagorean theorem, 4 squared plus -5 squared equals r squared. 16 plus 25 equals r squared. That gives us 41 equals r squared. This time we get the square root of 41 equals r. So it doesn't work out as nicely as before. However, we can now say that sine of theta is equal to -5 over root 41 cosine of theta. Okay. The x value over the r value would be 4 over root 41, and tan of theta will equal -5, the opposite, the y, over the x, which is 4. In conclusion, to find the trig ratios for any angle of rotation standard position given a point on the terminal arm, draw the vertical line segment from the point to the closest part of the x-axis. This will give you a right triangle that includes the reference angle, and using theta sub r, determine which side should be considered the opposite, the adjacent, and the hypotenuse. If you can remember, though, that sine theta is equal to y over r, cosine x over r, and tan of theta equals y over x, that'll be much quicker for you.